All right, so if everyone is ready, we will start this second session today. The title for today's session is Disrupting the Jewelry Industry. As I was telling yesterday, for just in case that any of today's assistants was to the yesterday session, this is our first Gemvision Virtual Summit. This Gemvision Virtual Summit consists in one session per day for 1 week, where we will be talking with different guests on what challenges the jewelry trade is facing and how Gemvision products can assist with all these challenges. So today we have Chris Leonard and Brett Norcutt. So I will introduce ourselves. So I will start with myself. I am Oriol Cullelamon, and I am the Gemvision's product director. My main duties are gathering all the customers' feedback and communicate it to the development team and to the stakeholders. And from all this feedback that we get, build MatrixGold and CounterSketch. Once we have all this feedback in our products, then we have the sales team and the marketing team that is the pipeline where we communicate it to all our customers. So it's like a circle where we can get all this feedback and then translate it to our products. As you already know, Stellar is the biggest manufacturer in US. I always like to say that even I visit jewelry business around the globe, I have never seen a business like Stellar which can provide to users any product related to jewelry. And one of the Stellar's big department that it's amazing how many different products they are carrying is the tools department. And today we have Chris Leonard and Brett Northcutt who will be joining us on this session talking about what are the next steps after the CAD design is ready. So in Gemvision, we always talk about our softwares, how to design either in MatrixGold or CounterSketch. I think that it's also very, very interesting to see what the next steps are. So today we have these big professionals with us that will be helping and walking us through all the process after we have the file. And many people is asking me once the file is done is what is the next step? So today we have the answer to this question. The way that we have been thinking about this, because the whole process is quite long. So I will be in live designing the ring that then will be print and cast. But of course that the printing and casting, this process is quite long. So what we did is we record a video that it lasts 25 minutes, but it's super, super interesting. There is a lot of very good information about the printing process, the casting process with information that I feel like coming from someone like Brett Norcutt, who has been working on that for a long time, all the participants will love. So now, Brett, if you want to introduce yourself, and then Chris, if you don't mind.
All right. Again, Brett Northcutt. I'm a process engineer in R&D labs here at Stellar. I've had the privilege of working in a lot of places. I'm a jeweler by trade, and I get to work in R&D and invent new things and do a lot of experiments. My specialty has been in the digital manufacturing world. So 3D printing, CAD and CAM processes has been my passion. So we're in the same boat that you guys are in, learning how to work in this world and get good results through printing and through direct casting of the polymers. It's quite challenging. So I'm hoping that today you'll learn some things, and we're basically giving you the recipe book on our end, and hope that we give you great success. Chris?
Thanks, Brett, and thanks, Oriol. Good morning, everybody. Thank you so much for joining. As my colleagues were saying, my name is Chris Leonard. I am the Equipment and Machinery Product Manager here at Stellar. So I work in the back of store merchandising division. My primary role is to make sure that Stellar offers the best and the newest technology in terms of equipment and machinery related to jewelry manufacturing, not only here at Stellar, but also for our customers like you at home. So a lot of the stuff that you're going to see in the presentation today to actually make the piece of jewelry come to life It's my job to make sure that we have that available for you online in our catalogs, etc. So I'm very excited to be a part of this, and I'm here to answer any questions that you may have about what you see in today's presentation. So thanks again for having me.
Thank you so much. All right, so you can see what professionals we have today. So as I said, it will be a very, very interesting session. I can already see for the amount of participants that we have that the people is just willing to see all the process in action. So what I will do, I will share my screen. Today we will be working with MatrixGold, the design that we have been using to make the whole process. It's been designed in MatrixGold. So I think that will be interesting. That for the next, I would say that it will take to me around 20-25 minutes to design the whole model from zero to the model ready to print. And yeah, then I will end the video, and at the end of the session, then will be the time to open the Q&A. So if there is any questions, that for sure that will be, I expect a few with all that we are talking about today, then Chris, Brett, and myself will be there just to reply any question. Before I go any further, I would like just to mention here that for all the attendants that will stay until the end of this session today, we will send them an email with 5% discount for if they get any of the Gemvision software. All right, so it's important to say it now before you left. All right, so let me go and close this presentation. This is not what we are looking for, and we are looking for MatrixGold. So as you can see, we will start from zero. So I will start from zero, and what we will be designing today is a three-stone ring, a three-stone engagement ring. And I will start, as most of the times we can start either with a ring rail, or in this case today, I will start with a cathedral ring rail, right? So this is the cathedral ring rail. It's very easy to make any change. So always keep in mind that while you are working in curves, it's always easier to make any change. So the first thing that I will do is to get the stones that I'm interested. So I will get the Gemvision ring rail. And as you can see, is getting as a reference this curve here. So this is the location 0, and this is the location 1. So if we want to just in the middle, the only thing that we need to do is just go to location and click 0.5. So we get it just in the middle. Today, I will be using a cushion cut, and the dimensions that I will use will be around 7.2. About the height, I will be able to move it later on. So now I want a heart shape gem here on this side. So again, I will do the same. If I click enter, I launch again the last tool that I've been using. And now I will place it just here. Let me change the shape. So I will go for a heart shape. As you can see, we have many different shapes. I will make it smaller. Something like that. I will move it a bit lower. And now what I have to do is just rotate it. So rotation, we will go to 90 degrees. I always like from the top view to have this look that it seems that the stone is touching each other. So I think that this is how it looks, very nice. So now that we have the stones as a reference, now is the time to adapt this cathedral ring to this stone. As you can see, I'm just working on this side. I don't need to do any work on the other side, because then at the very end, as the last step, what I will do is a mirror with all the work that I have done on this side, and I will get it on the other side. And because we are working with the parametric, any change that I do on this side, it will happen on the other side. So this is one of the power of this MatrixGold. All right, so now the next thing that I will do is just start to work with this cathedral ring. All right, so probably what I can do is add a profile. So I will go to the profile placer. I will select the curve. And because I want to place the profile between these two curves, I will choose the outside curve, and I will use this one. So now the height is already set. The only thing that I need to do is choose what width do I want. So I will go quite narrow, and I will choose another profile. So this is the one that I want. I will place another one. If I click Shift, I have the snap just in the middle. And now on this one, because I want to taper, I will go to 3.2. Perfect. So far, this is what I'm looking for. The next step will be going to the surface and using the sweep tool. The sweep tool is because we are using two rails, so we are using 1 and 2. And now the profiles, that is this one and this one. I click enter, and from the moment that I click enter, I already get the sweep. I can keep, as you can see, if I just click here, I can get, let me just go to the wireframe, the end open, right? So because I will do the mirror later on, so I can keep it like this. I don't want the mirror cap, so let me go now like this. And now I can select if I want one of these two sides close or open, right? So if I just do like this and start DOM, then I get it open from the end and close at the start. Cool. Now let's go and move this cathedral ring. As I said, everything is parametric, so I can go back to the cathedral ring, edit, always move it from the tools that we have in the right panel. Don't try to use the Rhino Gamble because then you will be breaking the history. And now the only thing that I need to do is just move the cathedral to have a nice shape like this. Probably I can make it thinner here, so now is the time to do it. Now probably Brad is thinking, Oriol, you are going too thin. I have to print this later on. So I will keep it like this. The next step that we will do is just work on this bridge. So I will select the bridge. Again, I will select the profile placer. I will just click on this one. Now I don't need to use any outside curve. I can go to 1 millimeter and I will use the mirror profile. So now I can go to the sweep one and say, with this rail, just please select this profile and this profile and give me a sweep. Profile placer, I will make it narrower so it adapts to this cathedral ring, and there we go. So now I have a reference for the stone, and I think that the height is quite accurate, and I will keep it like this. Let's gonna work with the settings. So I will use, for this central stone, I will use the head. On this head, I will use just one rail, and from the level 4, I will move this rail below the stone. Like this is okay. And then I will get back to the level 1 because I want this to be, we have these different ways to finish the bottom. So I want it to a point. This is how I want it. And now what I will do is I will bend it as much as I can because I want a round shape. So this is what I like to have. I also like to have that finish that it looks like the claws are just in top of the stone, on top of the stones, because at the end of the day, what we want to do is just present this design to our customer, and we want them to believe that the design is already done. And to do that, we need to make it like it has been already finished. So like this, and now what I just need to do is just to rotate it. Like this is perfect. And I feel like this one is too roundish. So what I will do is go to the prompt profile and I will select this one. Now this is the bottom. I need to go to the top. There we go. Very nice. What I can do is, this is going too deep inside the bridge, so I will just bring this a bit higher. And now this is what I was looking for. All right, so we have already the first setting done. Now let's go for the second one. On the second one, we will use another technique. So the first thing that we will get is the gem guides for this stone. All right, so we get these 3 positions, and now we will start to place the profiles. Let me show you how are we going to do that. I will move this bridge into another layer because now I want to hide it. And what I will do is just place one profile attached to this rail. The reason why I'm doing this is because I want to keep it parametric, meaning that if later on I have to just move or change the finger size, I will bring it to the 0.5. I won't have to do anything because it's already attached to this green rail. So I will go for 1 by 1. So 1 here. And I will move it. Even I'm moving it here, it will be always attached to this green rail. So any change that we do to the finger size, we will get it in the same position. And very close, I will add another one because I already know what profile I want to use on this side. And for this one, I will use this one. And I will rotate it 180 degrees. And again, what I will do is just make something like this and move it up to here. We can then make any change that we need. All right, so now we need 2 more profiles, one on this area, another one in this area, and then I will show you what's the next step. So profile placer, again, 1 by 1, because the one that I added just at the bottom was 1 by 1. I will just bring it a bit higher to have room to set the stone. And again, I will do the same on this one. I will change the profile for this one. I will use the same triangle that I used before. I will do the same that I did, that is just rotated 180 degrees. And now I will bring it in to have room to set this stone. All right, I will do the same that I did with the other one. I will move it a bit higher. Probably I don't need that width. I can go a bit less, like this. All right. So now we have all the profiles. What's next? So let me hide this because you will see what we are working with. We have this tool in Surface that is called the profile sweep that is very, very convenient on this scenario. So I select this one, and I already get this sweep. So I just move it like this. I just need to turn the automatic seam off. And I get this nice sweep, all right? Yes, I have everything. Of course, that if I want to go back and change anything, the only thing that I need to do is go here, edit, and I can start to play with this profile. So if I want to rotate it, if I want to move it, because it's touching the cushion cut, I can do something like this. And then I can even move it. And now I will finish it because as I was saying, I want to have a nice presentation for my customer. So what I will do is just go to tools and I will use the profile cap. All right, let's do the same for the other one. So Surface profile sweep. Now I will use this one and this one. Again, I will just bring this here. and I will drop. So we have a nice curve. Okay, I know that we have this, but I will show you how to work out on this part that it's coming out. So again, I will do what I did before with the profile cap curve, and I will go to the tools and profile cap. Fantastic. All right, so let's again, as you can see, these are all the steps that we have been working on. Everything is parametric, so at any given time, I can make any change anywhere. So for instance, now what I would like is to rise a bit this cathedral ring. So what I can do is just go at the very beginning, go to edit, and now just try to adapt this. So I can go like here, and I will bring it even more inside, because now this looks just what I was looking for. All right, let me bring in again the bridge to see how does it looks like, and the head. So I believe that, yes, this is what we were looking for. Okay, the next step will be, I will get this surface and this surface, and from transform, I will do a mirror because I want it on this side. So I will have exactly the same. Now I'm getting it here, so the only thing that I need to do is change the plane, and there we go. So now any change that I do on this prong will happen also on this one. So if I want to go back to this curve and just go to edit and open it up a bit, I can go like this and move it. So we can adapt it to what we want. So this software is super dynamic. It's allowing you all the time to make changes. This is where the beauty of this software is in the parametric side, is that most of the times, either because the customer wants some changes, or either because the designer is, after have done a few steps, he wants to go back and make some changes. This software is super flexible, so it's very good to work that way. All right, so we are almost there. The only thing that now we need to do is, I would like to add this piece that we have just on this area. To do that, I have different options. I will show you that from gems, you can get a gem offset. I can bring it down. I can open it a bit. And now I will trim this curve. So I can go to curves and I can trim it. So let me just go to trim curve. And this trim is parametric. So at any time I can go back and just make any change. And I will go from here to here. Now I will import this part. So now we have this part, and this is the part that I want to use to just place it below the stone. The cool thing in this step is that we will be combining two different histories. So we have from transform, and now I will have to minimize MatrixGold because I don't see all the tools. So in transform, we have the flow, right? So this is the tool that we are going to use. So just let me make it bigger, because I have the application bar that does not allow me to see this. But actually, because I can move it, this is the cool thing of MatrixGold. I will move it to here, and now I can go to bigger, so I have it just here. You see, this is one of the cool things about MatrixGold, that you can do anything that you want. So I will go to front, and now I will use a curve. Line, and I will go from here to here. So we have this curve, and now the only thing that we need to do is just say from transform, flow along a curve. You need to follow what the command line is asking. So select objects to flow along the curve. This is the object that I want to flow. Base curve. The base curve is the one that I just drew. That is this one. Just a second that I click twice. So again, objects to flow, base curve, and now target curve. This is the target curve. And there we go. As you can see here, I have the record history. This is the record history from Rhino. This means that now, because we have the record history from Rhino on, if I just get this object and I just rotate it, you see that the same is happening in the one that we added there. And the cool thing is that it's following the history from Rhino. But now if I go back to the step where I was using the gem offset curve, even its height because I trim it, but I can go back to this one, edit. And if I want to bring it in, the only thing that I need to do is just bring it in. And now you will see, once I click enter, how everything recalculates. I think that I didn't bring it in. Let me see. So now it's 0.2. There we go. All right. So again, what I will do is just do a mirror. Not on this side. I want it on the other side. Fantastic. There is not much left. As I was saying, let me hide. I want to remove all this area from this ring. Again, what I can do is to go to gems and get the gem offset curve. And from here, I will validate and I will just do an extrusion from curves, extrude curve, both sides, cap, and let me just go a bit further. Fantastic. So now I go to solid and Boolean different. Boolean different from this and this. Yes, Boolean difference between this part and this part. And as you can see now, it looks clean and nice. All right, just perfect. I think that I have almost everything. The only thing that is left is just the stones on this area. And then, as I said at the very beginning, we will do the mirror for everything. I don't know how long it took, probably it's around 25 minutes now. So let me speed it up. I will extract ISO curve, select the surface. This is the surface where I want to start this, the curve, 0.5 to just place it in the middle. And now I will use this curve to place the stones, gems on curve. I want the end position to be here and the start position to be just in this area. I will select taper at the end, make it smaller here. I will add another one. And the way that the placement method that we'll use will be the table, because now we need three different cutters here. The first one is the channel cutter. I will make it smaller because just let me go like this, smaller than the stone's diameter, like this is okay. I will choose the micro prong cutters. As you know, you can make any change that you want. We'll keep it like this. Great. And again, I will select the stones, and the last one will be the gem cutter. Fantastic. Okay. Now the only thing that we need to do is just go to solid, Boolean difference, between this part, and clicking on the right button, I select all the cutters. I click enter, and now it's performing all the operations. As I said, keep in mind that this is all parametric. So still, if I want to make any change, if I want to add the stones, if even the Boolean is done. Now, if I want to add any stone, I can go just the step where I have the gemstone curve on this one, and I can add stones. If I want to change any profile, I can do it with no problem at all. All right, so let's go for the last step. So it's 1, 2, all these parts. I will try to don't forget anything. All right, so I think that I have everything. And I will go again. As you can see, I'm using a lot the mirror. There is many times that our jewelry is symmetric, so using the mirror is something that is speeding up a lot the whole process. So now it's just getting all the different steps that we have done. And there we go. Okay. So we have the ring ready. And now I know that Brett is thinking that he told me, Oriel, don't forget to tell this everyone. So very important for the next step is that now we need to do all the supports. To do the supports, let me just move this again. I will go to manufacturing. I will use the sprue. Is asking me select the ring. This is the ring. And Brett was asking me, Oriel, just keep in mind that at the very end, you need to use the mesh repair. So we have just one piece. So I will do that, Brett. So we have one. Now I will use also the finger hole support. Just let me get rid of this one now. Yes, I don't care now. Okay. And I will place one just here. Let me use the X. And I'm not sure how many Brett add because Brett add. So I click enter. This should be okay. And now I'm just going to place the supports that Brett added, but he will tell you why. I believe that is very, very important, all the information that he will tell us. But I will add just one from here to here. I just will say that I wanted 0.5 start diameter and end diameter, also 0.5. Then I will get another one just from here, and this one will be thicker, start diameter to 1.5 and end diameter to 1 millimeter. So I will place this one just here, and then Brett add a few more just here. So let me go again from here to just this area, and then he added a couple more just from here, and now the end diameter will be thinner to these two guys here. So first I need to click enter. So he added just one here and another one from here to this other point just here. All right, I think that I have everything. So let me just select 1, 2, 3, and do the, let me just first do the mirror from this one. transform and do the mirror. Great. And now the next one, the next step that we'll do is select all these parts. And again, use the mirror. I don't know how many times I have used the mirror today, but as you can see, it's super, super helpful. Now I will select just these two guys with Control Shift to then select all the other ones, and this one and this one. Perfect. And the large mirror. And this is a design ready to bring to the printer. As I was telling you, Brett told me to don't forget the mesh repair. So anytime before you send it to the printer, it's good to have this in just one piece. So the only thing that you need to do is just select everything and use the mesh repair. The mesh repair, what we'll do is just close all the different areas and just bring them into one area. All right, so now it will take a while. So I know that we are running out of time. So what I will do is just launch the video that we have with all the process once we send this to the printer. So just give me a second.
Oriol, hey, this is Chris. It looks like we have a couple questions in our chat.
All right, let me just go there. I will stop sharing. I will go to the Q&A. Well, we have 3 in the Q&A. Do you need, Jane Weber is asking, hello Jane, how are you? Do you need to join the left and right side of the shank? No, because I was using the mesh repair. So at the end of the day, we were using the same profile. And so we were going from the center profile to the left and the center profile to the right. So because we use the mirror, and this is one of the good things about the mirror using the mirroring, is that you are closing the surfaces. So at the end of the day, you have a closed polysurface. And when you use the mesh repair, you get a very, very nice mesh. Why do you need the little sprue on the side? Now, Brett will be telling us why.
Right.
So this is so super amazing.
So you'll see in the video next why we put those little connections. They're not to negative facing geometry. It's there for structure to keep the part rigid during printing. So when we watch the video, you'll see some more examples of that.
All right. Okay, so I think that we have gone through the 3 questions that we had in the Q&A. And now what I will do is just share. Let me just bring it on. So we will go here. Perfect. And share a screen again with the sound and share. We will click play.
Hello, I'm Chris Leonard, the Equipment and Machinery Product Manager here at Stellar. I'm with my colleague, Brett Northcutt.
Hi, I'm Brett. I work in the R&D Labs department as a process engineer, specializing in digital manufacturing.
So today we're going to take you through the entire process all the way to casting. So Brett, if you could just walk us through a little bit what you have here set up.
Sure. So this is the entire B9 creation setup. So I have B9 2.0 software that I'm going to work with the file and create a file for the printer. Here is the B9 550 machine, which is going to do my printing for me. And this is the B9 Clean that'll clean the parts with 99% isopropyl alcohol. And we have our B9 Cure. Our B9 Cure, we're going to cure the parts actually in water to keep the oxygen off of the part. So
All right, so Brett, now that you have a supported file, could you walk us through exactly how you're going to use the program to get to this next step?
Sure. So first thing we're going to do is have the software open, and we're going to set up our machine. So we're going to select the B9 Core 550, and our material is yellow. We're going to use the yellow resin for our purposes today. We're going to browse for our part. Our part is already supported, so we're going to grab this part and open it and import that file into the software. Now what we're going to see is the part actually simulated on the platform. So here's what we're working with.
So Brett, these supports were already existing when you imported the file?
Correct.
Gotcha. And that file was produced in MatrixGold, I'm assuming?
Correct.
Great.
So all these wires and pipes that you see are not part of the model. These are supports for the 3D printing. So the easiest way I can explain how this is working is that any negative facing, what we call negative facing geometry, which would be, the bottom of this loop here, it's facing downward. And in 3D printing, we can't go up and back down. So we have to feed those negative facing geometries with a feeder, and normally we use these pipes to do that. So this pipe is connected all the way down to the bottom base. So we start printing actually down here at the very bottom and work our way up to the top. There are supports also that are necessary for supporting the model itself as it's printing, because we like, for instance, the middle portion that you see here, that's not negative facing, but it's necessary to keep the part rigid as it's being printed, because there are some forces that are happening as it's printing, and we want to keep the part stable and not flexing and moving around. So these central supports here are for that reason.
And will this B9 software recognize where a support is needed?
The B9 software is capable of supporting, and it will show you support regions. In this situation, we supported it in another software, which is fine. You have the choice of supporting within the software or supporting in the software that you choose. Mm-hmm. Everybody kind of has their preference here. Here you can also see another support that's put in for stability reasons, not for negative facing. But these little jumpers that you see here are for negative facing. So connecting from the main body of the shank up to this little edge, which is negative facing. So if I wouldn't have put this support here, this front part of this design would not have printed.
Gotcha.
So supporting, guys, is the name of the game. Success or failure would be based on supporting. So it is extremely important that you catch all of these negative facing and all of these areas that you need to support to keep the model rigid during printing. Without that, you risk the failure during printing.
Is it possible to have too many supports?
So that's a great question, actually, because you can over support to make sure that you're capturing everything that's on there. Mm-hmm. But if you've ever removed supports, you'll understand that too many supports makes it almost impossible to remove them without damaging the part.
And I'm assuming it will increase your printing time as well.
Not really increasing printing time, but it will increase your effort to remove them.
Sure.
and remove them without damaging the part.
Makes sense.
The last thing I'll say is at the very bottom, we have what we call a base plate. The software can add these little platforms or base plates. They are necessary so we can get good adhesion to the build platform itself. Without that, then you run the risk of the part falling off during printing.
Okay.
So I would suggest you either have these shadow bases, or you put a base plate around the entire build envelope. So about 0.3, 0.4 millimeters thick all the way around
the platform itself. And
Right.
that'll help the parts stay, you know, on the platform and not pull off.
Gotcha. Now, obviously, we just have one ring here on the
Right.
screen. How many rings could I fit on this build platform?
So let's just see how many parts we can fit on here. So we'll progress this to the next step, and we'll key in. Let's try 9 pieces and see what that gives us. So that kind of worked out perfect.
Wow.
So there's no need to really auto range anymore. You know, I could probably, you know, manually move some things around and fit some more parts, but this looks good to me.
Looks automatically centered.
Yeah. So you can see here the color in the model is actually showing, you know, where supporting might be needed. I will take risk to try to minimize the amount of supporting I'm putting in, but not too much to where I fail.
Right.
So that's really the secret, trying to figure out, you know, the least amount of supporting so that when we remove it, we're not damaging the part.
Right.
So we'll continue on the path here. This is some more supporting tools within the software. I don't need it at this point because everything looks good to me. And we're going to finally slice this file, which means that the software is going to then take this and create many hundreds of layers, because we're 3D printing in layers, right? It's one layer at a time until we get to the very top.
Right.
So software basically creates a picture, a black and white picture of the layer itself. So when we're projecting, where the white part is the projected image, that's going to cure that layer to a solid.
Okay.
So we'll save this. And it'll take a little while. The software's crunching all this data, and then you'll see it'll start showing us the slices being created.
Is that what's also known as resolution?
No, resolution is actually 2 things. It's our XY resolution, which is the size of the pixel in a projector system. The smaller the pixel, the better the XY resolution.
Okay.
So we want, you know, as small as we can get with, but when we go smaller with a pixel, our build size gets smaller.
Gotcha.
Okay, so it's a balance of, you know, the best pixel with the best build size that we can get.
Makes sense.
The Z is another resolution because we can choose how thick to slice it. Here at Stellar, we're slicing at 25 microns. We find that that's the best size, but you know, if you get in a hurry and you want your print to go faster, then a thicker slice is what you would choose. But you would have probably some more stepping in the model itself because we're taking bigger layers at a time.
Gotcha.
Right.
So-
Smaller layer at a time gives us better surface resolution in
Makes sense.
the Z axis. But
Okay.
XY is a thing, so it will produce textures on your part as well.
So what's the upper limit of Z axis? You mentioned 25 microns
Right.
being an ideal setting.
Right.
What's kind of the upper limits of that?
For jewelry, I would not go past 50.
50?
Yeah.
Okay.
Yeah.
Okay. So
25 is kind of the sweet zone.
right. Okay, so lower the microns, more detail, but more printing time.
Less printing time for a thicker slice, more printing time for a smaller slice.
Gotcha.
Because you basically doubled the layer count by going to 50 microns.
Makes sense.
So as you can see in the software now, it's building this slice file, and you can see the models coming to light here. And once this is complete, then I'll just grab the file from the computer and then move it to the printer with a USB. And we'll move over to the printer.
So we're moving over to the 3D printer here. You mentioned that this was the B9 550. I believe this is the Core series. Could you tell us a little bit about the machine, its features, and mainly what do you like about it?
You know, visually, I really like the machine. It's well built. This is all metal. There's no, you know, plastic in here. Very, very cool, you know, door to open to get into it. There's a lot of visuals here to help me make sure that I have everything in the right place. Mm-hmm. So it's just easy. Mm-hmm. I don't have to worry about calibration. As long as I get the platform in there and I get the vat with the material in position, then I just start the machine. And it
yeah,
works.
it's funny you mentioned that. I've heard the term 15 minutes and 5 button presses, and you can start 3D printing. So glad to hear that that it is truly that easy.
So let's start by getting some material into our vat. Make sure that we're wearing gloves. We don't want to get any of the resin onto our skin if we can help it. So gloves and a lab coat will be advised. And again, we're going to demonstrate by using B9's yellow material. Mm-hmm. I find that this casts better than any of their other recipes. Mm-hmm. So one thing we want to do is make sure that the material is well mixed, because resins can separate. So give it a little shake, but not too much. We don't want to introduce bubbles if we can help it.
Mm-hmm. And how do you normally store your resin? Does it have to be
room temperature? Just out on the counter is fine.
And it comes in these 1 liter
correct
bottles. Okay.
So we don't need to put a whole lot in here, but that should be sufficient.
Brett, could you tell us kind of a little bit about what a photopolymer resin is?
Okay.
Why is it used in the process?
Photopolymer means that through light, we create a crosslink from a liquid to a solid. Mm-hmm. So it's really, you know, the easiest way to explain it. If I expose light to this, even the lights in this room are starting a reaction, mm-hmm. And it will turn this liquid to a solid.
Wow.
And that's really the way it works.
It's really neat. So it doesn't look like you put a whole lot in there. Does it tell you how much to use, or?
I don't think there's a max line here.
Oh, okay.
But that's a lot. You don't really need to put that much in there for one print.
But you don't necessarily have to measure it precisely. That's good to know.
There's a way to do it precisely if you want to try to get it to use the least amount of liquid before you move to your next build.
Okay.
But I just eye it up normally.
Seems
so
pretty simple.
You know, you push this in, you see this green bar, that means that it's in position. Okay, if it's out here, it's not in position.
Okay.
So I like the visual clues here to make sure that, you know, we're in the right position. And then this is our build platform. So one thing I like about B9's process is every platform is universal to fit and work in every machine.
Oh, that's neat.
There's no calibrations to do.
And I'm assuming that different machines from B9 have different build platform sizes, etc.
Right. Okay. And once you move up to like the 550 XL, mm-hmm. then you get a bigger platform.
Okay.
So once that's done, everything in here is complete.
And you didn't have to put anything on that build platform. It's just metal.
Yeah, I just need to make sure that it's clean.
Okay.
So we want to make sure that from the previous build that there's not any cured bits on there, because that can actually damage your vat.
What should I use to clean the platform?
99% is what we 99% isopropyl is what we use.
Okay.
It's pure. It works the best. So we just wipe it down, try to get all the uncured resin off of there, and then you scrape off any cured bits.
Gotcha.
So using just a little spatula, whatever, to scrape the cured bits off.
Easy
You got
enough.
to get that off because that could drive down into your film and the vat and damage it.
Right.
So very important to keep your liquid resin free of any hard bits that cured in there that may have failed and broken off, and any cured bits on your platform.
So no bits, no bubbles.
Bubbles,
keep it clean.
is kind of hard to eliminate the bubbles, but I don't see a whole lot in there.
Not too bad.
You know, when the platform comes down for that first layer, it's going to squish any air out.
Makes sense.
So let's get the machine going. we're going to look for our build, and we're going to move that into the printer and activate it. So we're copying the build file into the machine system.
And when you first got your machine, did this take a while to learn, or was it pretty easy to understand, just following some steps?
Reading a few instructions, it
Yep.
seemed, very simple. Now, I have some experience with printers, but
Sure.
An inexperienced person with reading through the instructions will have no problem.
So somebody like me who's never
Correct.
done this before.
So once we get the print to register here,
Mm-hmm.
the transfer is complete. We're going to move into our library of builds, and we're looking for our build, which is right there.
Oh,
we
wow.
can see it visually.
Nice visual, yeah.
Then we'll continue, and we're looking for the material, right? So there's a bunch of materials here from B9. We're looking for yellow, and for this example, we'll do a 50 micron slice in the Z-axis. But we have these other options all the way up to 90 and all the way down to 30 if we choose.
Mm.
Again, the slice will determine Z resolution,
Mm-hmm.
and could be textures and steps,
Right.
but our build time is 57 minutes.
Oh, so it tells us right there.
Right. So that's extremely quick.
What's another common machine with a build of this size? How long would that take?
As an example, Stellar uses some Envision Tech machines, CDLM machines that are similar. And they're close to being at the same time, but the B9 actually is a little quicker.
Gotcha.
So a couple of hours
Mhm.
for a 2 to 3 hours for a 25 micron slice
Okay.
build. And it doesn't matter how many parts are on there.
Mhm.
What matters is how tall the tallest part is.
Interesting. Okay.
Okay, so it doesn't matter. You could build a whole block in there. It's the same time as if we had a bunch of ring models.
Good to know.
Yes. So let's just print.
All right, Brett. So we're done 3D printing. Can you walk us through what happens next?
Well, look, we have parts. So success.
All right.
So first thing we're going to do is reach in and loosen this screw at the top. Again, want to be very clean as we can. We don't want to drip any resin around here because that
Right.
will stain the machine. All right, this is our clean unit. And there's a little device here where we just slip it on, just like we do in the machine,
Okay.
and tighten it up. And we clean the parts on the platform. We drop it in. We set desired time. In this case, we're going to do 2 10-minute cycles in cleaning. So set the timer for 10, start the machine. So IPA is going to pump up into the reservoir here, and then once it's there, a stirring action will start, and we're going to do 2 10-minute cycles. So our cleaning cycle is done. The IPA has pumped out of the reservoir, so we're free and clear to remove it. What we want to do, let this drip off a little bit, and we want to dry these before we go into cure mode. So a little air blast, and what we're looking for too is if there's any shiny parts. And that indicates that we need to continue to clean.
So any hair duster will work?
Yeah, usually you have an airline, or a compressor to do that job.
Gotcha.
All right, so next we want to remove the parts, and they come off pretty easily. So just a little scraper, we can pry against the bottom, and they come right off. So once the parts are off, we're going to go into our curing process. So what we want to do here, this is a really neat feature of the B9 Cure, is that they built this clear container, and we put water in it. So the reason for that is oxygen present on the surface of the resin will inhibit the cure. So the water, submerging in water, takes the oxygen out of the equation. So it's pretty cool feature from B9 here. So just drop them into this water.
Brett, just regular natural water? Is it deionized water or anything like that?
It's smart to use deionized or distilled.
Okay.
Regular tap water will end up putting deposits in here.
Okay.
Eventually it'll create an issue for you. So make sure you're not getting water everywhere. And we're gonna open the cure box, slide this into position. Close this up, crank it up. We're gonna set the machine up full power here with a strobe, and I'm gonna go ahead and maximize this all the way up to 30 minutes. And we'll start. Now you can set it to strobe or you can set it to constantly on. I think constantly on is probably acceptable, and I think you get more coverage of light, but strobing is acceptable. So we're going to let that run 2 cycles of 30 minutes each. All right, so our cure cycle is complete. Grab by this little handle, pull this out, be careful not to spill any water, and we just reach in here and grab our parts and let them dry on this towel. So after this is done, our parts are dry, then we're ready to go into support removal. So remember, we have all these pipes and supports that we prepare for this model for printing. Those have to be removed. So we're going to remove those supports and then add a wax runner, a little wax extension, because we want that connected to our wax tree. One thing that we use here that we're going to share with the world is that a product off the shelf, Rust-Oleum Clear Coat Gloss, so it's a 2x ultra cover. If you use this product and spray a barrier coat on the resin, that gives you a better shot of getting a good casting. So there's a theory of resin reaction happening in the mold. It also has a side benefit of smoothing the part. So it's actually wicking in and making the part smoother. So taking some of those grow textures out of the picture. So it's a 2-benefit situation here.
What a great tip. Thank you.
So what you want to do is spray the part and let it dry thoroughly, and then we move on to spruing up on our tree. Once we're sprued on the tree, as such, we're going to invest it like normal. Stuller in our internal production uses R&R Plasticast. I would advise that you use that product. Follow the instructions there. We're going to provide you with the actual burnout schedule, and you follow that, and you'll have use your normal casting process after that. And that's really it, guys. I think if you follow those instructions, you'll have the best success, and you're going to use the same process that Stuller uses on a daily basis.
I hear we're actually going to be bringing B9 on here at Stuller, so that'll be exciting, huh?
Absolutely.
Yeah. And folks, please keep in mind that if you'd like Stuller to handle all of the casting procedures, just simply contact our CAD/CAM services department. They're happy to help you out. But for those of you who would like to do all the casting at home, Stuller has all of the equipment and supplies that you would need. Just please visit us on stuller.com, or you can contact our Tools Technical Support team at extension 4300, and we can find exactly what you need.
Thank you.
Thank you.
All right, amazing video. I love it. I will keep this in my archive. Okay, so there was a few questions that either Brett or Chris, they were just replying. So now if there is anyone who wants to ask anything else, let me see. We have also a few questions on the chat. I'm going to read and then either you, Brett, or Chris, you can just answer.
Yes, sir.
There is Juan Santiago who's asking, does the process varies depending on the resin, emerald versus yellow, or is the same?
The process would be the same. So
All right.
the cure, the clean, the spray barrier is the same.
Shinya Takahashi is asking, what was the name of the spray?
Okay, it's Rust-Oleum clear coat, ultra cover.
All right.
Two times ultra cover.
Just for all the attendees, we will post this video later on, not tomorrow, but probably I think the next week. So all the information will be there for in our YouTube channel. So anyone who wants to see this information will be posted there. There is in the chat also another question. You mentioned that you are making the clothes for client presentation, but we cannot set like that. Do you go back and adjust after you have presented to the client? Yes. So this is one of the beauty of this software. Even I have done booleans or any other step after I just designed this clothes. I can go back to the step where I was designing this clothes and just go back the way that I did it. So I was just moving the clothes on top of the stone. What I can do is just move them back. So then we can set, or we also can enlarge this clothes. So then we have more metal to set the stones. What kind of issues does having oxygen present during curing cause? Brett.
That's a good question. You know, it's documented that, you know, oxygen present during curing, it suppresses the cure. It inhibits it. So not always are we curing, you know, in a system where we're taking oxygen out. Water is one way. We could use an inert gas as well. And it's just another way to ensure that we get proper cure, because without proper cure, we start to have issues in casting. So we want to make sure we get the best cure possible. And that's one factor that we can take out of the picture by removing the oxygen from the surface during that cure.
Great. Sterling Vanderwerker is asking, what do you calculate for the part cost per piece in V9 wool?
I'm not sure about that, but we can come back to you with that answer.
Carmen Kauser is asking, I have been using curing resin. Is it then better to use water even if you don't have a benign curing machine?
Yeah, you could, you know, use a glass beaker or anything that's going to allow, you know, some light to penetrate there, and put it in water and cure away.
All right. So far, I think that we replied all the questions that we have in the chat and the Q&A. It's now, well, we are 10 minutes past 1 hour, so has been quite long, but I believe that has been very, very, very interesting. So all the information that we put together from MatrixGold, designing the whole piece, and then doing all the process with the printing and the casting, with all the tips that Brett was telling us, was amazing. So very, very good.
It's been my pleasure.
As it looks like we have one more question from Lori. It's a CAD question.
This is a CAD question. Does the tech report give precise weights without booleaning all the parts of the model together? No, it's always better to use the boolean. So when it's time to get the weight, if you don't use the boolean, what MatrixGold will understand is that you will have all these parts at their own, meaning that if they are not joined, you will get a higher weight than what it will be. Then Frank Haloff is asking, new question, sorry, is any planet development to create this in Max environment, or is it Windows only? MatrixGold, I can imagine that he's talking about MatrixGold is so far it's just for Windows. There is people who's using it with Apple using the bootcamp, and so far there is no problems. But we always develop and we test it on Windows. So when it's someone coming from Mac, all the process that we have done, all the development that we have done it on Windows. Linda Suzuki is saying excellent presentation. Thank you. I agree with you, Linda. Brett and Chris, they did an amazing presentation. And I think that the information that we have put together is very, very useful. All right.
Oriel, if I may, I just want to let everyone know that for those of you who are interested in the B9 suite of products, we are finalizing our partnership with them as we speak, and we suspect to start offering the suite of products, I believe, in the beginning of August. For any of those who are going to be at JCK, we will have them in our booth as well, if you wanted to come see it in person and speak to some experts. But just pay attention to stellar.com. Any new news we have on any new equipment or machinery or tools and supplies, you can find there. So, and once again, don't hesitate to reach out to any of us or our technical support team with questions in regards to what you learned today. So.
Yes, and we will be in, as you said, Chris, in JCK. So that's a good place also to come there, talk to us, and see in real life what all this machinery looks like. And it's a good place to have a chat with all our team. Perfect. Then I think that there is no more questions. We're great. Thank you, Jane. And perfect. So I think that we are done today. And as I said, in a few days, we'll be posting this video in our YouTube channel. So if anyone wants to get any of the just phone numbers or any information that we were sharing in the video, it will be posted there. Or as Chris was saying, through stellar.com, you will find all the information. Keep in mind that as the last thing, we will send to everyone who has been in this session until now at the end, we will send them an email with this coupon, just in case that they want to get a 5% discount in our software, in MatrixGold or Counter-Sketch. So thank you so much. It has been a pleasure. Again, we have had a lot of attendees today, so thank you for staying with us. And tomorrow we will talk about the Academy, and for anyone who's getting MatrixGold or Counter-Sketch, how to learn the first steps. Thank you so much. Have a good day. Brett, Chris, has been a pleasure.
Thank you, everybody.
Yes, sir.
Thank you.
Have a nice day.
Have a great day.
Thank you.